Hello and good morning everyone. Today inshallah I will continue our lecture with functions. So we will continue functions inshallah. I believe today, hopefully, I was hoping to finish the part of basic concepts of functions, then going to the composite function and the inverse function today. But I will leave it as it goes with this lecture today. I guess if we could finish the basic concepts of functions and the domain and how to get the range and the graph and everything, this is going to be very good. Especially that I'm planning today to add some problems that already have been given in the previous exams, the first midterm. And I'm taking this opportunity. I want to talk with you about the next one. The next exam is just around the corner. It's going to be on the 9th of March or the 10th of March. I don't remember exactly, but you should check. It's already there in the lectures and in your table. So please try to study hard. It's really very important. And it's really very important to keep practicing. I want you to remember at all times that practice makes perfect. So it's really very important to keep practicing and also try solving more problems as much as possible. As we spoke previously, you know that at the model you have almost everything that you need. Also, the previous exams, most of the previous exams are over there, so you can check them and you can try them by yourself. It's really very good. It's a very good tool, and so you will be in a very good shape. Now I will start with the basic stuff that we already initiated in the previous lecture. We spoke about the various types of functions, either the single-valued functions, functions in several variables, and the vector-valued functions also. So it's really very important to keep in mind and to keep practicing as I told you. Today I will focus with the domain and also with the range, how to get the domain and how to get a speculation of a range, the steps of graphing your function and how it appears, either it is in 2D or in 3D or larger than this. The level sets, and we will go to the analysis of what's the level set and how to get it. Once more, as I told you, our course notes, references, everything you can find it on Moodle, and also the recorded lecture, you will find them on my YouTube channel. I usually upload them as fast as possible after we finish each lecture. Today, as I told you, I will initiate our lecture by the beginning of what to be in mind in order to get the domain of your function. This is very, very important. So once you are asked about defining or finding the domain, you will have to do the following. You have to keep in mind in all times those relations which will appear frequently in plenty of problems asking you about determining or defining the domain. First of all, if you have a denominator, of course the denominator shouldn't be equal to 0. If you have an even radical or if you have an even root, what's inside the root should be greater than or equal to 0. For the len, okay, or the logarithmic functions, the argument of the logarithmic function should be greater than 0. This is really very important to keep in mind. And last but not least, also the log function, it's exactly the same. The log function, you should check that the argument of the log function also is greater than 0. So once you are asked about domain, I want you to keep those in mind in all times. It's very, very important. Also, I want you to be familiar with the symbols. You already know most of them. صح, Mr. Omar? That's R, stand for from negative infinity up to positive infinity. R with a positive, it means 0 open up to infinity. If it is R negative, it's from negative infinity to 0. If it is r positive and 0, it means, Mr. Muhammad, that 0 is involved in your interval. So it is starting from 0 and above. Okay, hasn't seen the polynomial functions in general, which like b of x equal to x plus 1 or x squared plus 4x or whatever, all the polynomials, their domain is R, so it runs from negative infinity to positive infinity. Where the even radicals or the roots with even numbers, of course x is greater than or equal to 0, so it's gonna be covering the domain. This is how we can write the domain, a domain of the function. So it was an f of x, I will write d of f. If I have g of x, I would write d sub g. Okay, and the domain is r positive and 0, which means it will take from 0 up to infinity. Are you with me? Okay, so in this case, x is greater than or equal to 0, as I told you. So x starts from 0 up to infinity, or simply we can write x belongs to the interval of, or taking the positive part of the real numbers, including the 0, and this is how it should be run. If I have, for example, f of x equal a to the power of x, it means the domain running from negative infinity up to positive infinity. So there is no relation whatsoever on the domain, so the domain is going to be r. If you have logarithmic function, as I told you, if you have log x for base a, log x for base a, I want you to keep in mind that a doesn't equal to 1, and the domain in such a case, it's r positive. So the domain for the logarithmic function, log whatever to base a, it's exactly like len, of course. But len is a special case from the log, if you remember. Do you remember the base of the len? What's the base of the len? Why? What's the base of the len? It's log for base e. It's log for base e. Don't you ever forget that. Okay? And also for the len of x, the domain will be x greater than 0, which means the domain will run to r positive, as you can see. Here the argument must be greater than 0, as I told you. Remark, if we have more than one case, so if your function contains an alternative cases or multiple cases from this, I should mix and match according to what's going to appear in your function and take all the regression. For example, has it, if I have the square root of x minus 2 and divided by x squared minus 9, here I'm mixing the two conditions together. I will have to satisfy or to find the values, Ya Omar, of x that satisfy this function, that makes this function applicable, defined. If you insert the values of x, you will get a suitable or defined values in y. And this is really very simple. If I want to solve a problem like this one, it's really very simple. All I have to do is to take the conditions. So for example, condition number 1, I have a regulation that's x minus 2 must be greater than or equal to 0. Are you with me, Mr. Omar? Which leads to x must be greater than or equal to 2. That's the first condition. The second condition, the denominator shouldn't equal to 0, which means that question number 2, you should check or be sure that x squared minus 9 shouldn't equal to 0, which will lead to x squared doesn't equal to 9, which leads to in x doesn't equal to positive or negative 3. Now I need to find the common domain that will satisfy both conditions. And in such case, in this case, I can write that x belongs to starting from 2 up to infinity. 2 closed and the infinity is open. And in this case, this domain will contain positive 3. So I would say except the value of 3. Or I can write except 3. So I can write it either way. So the domain will be running from 2 up to infinity, but don't put x equal to 3. Of course, for the negative part, it's not involved in your evaluation. This is mainly the simplest idea or the simplest way to find a domain. Once more, the domain is the values of x or the values of the independent variable for which the function will give a defined values of the dependent variable. And also, this case or this discussion goes to the three types of functions. Do you remember them? The three types of functions? Okay. To the functions in several, the functions in one variable, and also same discussion goes for functions in several variables, and the same discussion go for the vector valued functions. In the previous lecture, we spoke about how many types of functions? Three of them. Functions, single valued functions or functions in one variable, functions in several variables, and the third one is the function or the vector valued functions as we know. Okay? Okay, very good. Now I will go to the domain of vector valued functions. The vector valued functions, you will have the input several variables, and the output, it will be more than one function. So the input, it's gonna be not just only one variable, in variables. And the output also will appear in plenty of functions as you saw. So for vector valued functions, f such that it's a subset from Rn into Rn, which means the input is n, but the output is m.
Okay. أنا بس بفكركم بالديدلاين بتاعت البوكس النهارده على الموديل. يعني أنا I send an email بس أنا يعني بأكد عليكم تاني.
هو كام جروب؟
مكتوب كله في يعني once you click on the link أو you go to Moodle and click on the link مكتوب كل حاجة عدد الجروبس. أهم حاجة ما تختاروش حد من هناك. أنتوا مع بعض. اوكي ديدلاين النهارده بالليل. اوكي شكرا دكتور عمر.
عم فهمت تحت امرك. فكرني ان ده هيتعدل. الورق ده هيتعدل تاني. كله للكل. الورق ده هيتعدل تاني. مخلص اهو. اوكي. يبقى for vector valued functions, as I told you, f such that d is a subset from Rn into Rn. Once more, Rn is the domain. What's entered the function. Rm is the output from the function. Okay? This concept is really very important, as I told you. Okay, how to deal with vector valued functions? Okay, to deal with valued functions, we obtain the intersection of the domain of each function of these functions. I will give you examples. So I need to find the intersection of the domain has an extract خالص. Okay? مش انا بقول اسمه صح؟ انا بقول اسمه صح. طب ما انت سرحان ليه؟ تصايم النهارده؟ Okay? طيب يبقى اذا انا as I told you it's very very important to determine the domain as you can see. Okay, if the function share the same variables, we should find a common domain to satisfy all conditions. This is really very important. With the vector valued function, you will enter variables and they will be the basis or the input for many outputs. Okay? Okay, let's see. So of course, the domain, as I told you, the general domain, it's the domain of the first function, intersection the domain of second function, intersection the domain, blah, 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 and so on. If you have various variables, we will add these conditions together. So if you have more than one variable, I will add them all together as you will see. Let's walk to this problem. This problem, Omar, it is running, please, the lecture, today's lecture, it's very important. It will set plenty of points in your mind. And it will be a basis for the next ones. So it's really very important. Okay? Remark, it will make you also more comfortable working around these types of functions. So it's an f of x. معايا محمد؟ بص الاوتبوت، the output is two functions, not one function. This is why it's called a vector valued function. The output is an R2. It will appear as a rational function and a radical one. A rational function and a root function. So if I want to see the domain of this function, remark has it that the outputs are still in the same variable, which is x. So the domain should satisfy that x, first of all, for the function f1, for f1 to work, x shouldn't equal to 0. For the second function, f2, to work, x must be greater than or equal to 0. I will have to find the intersection. I will have to find the intersection between them. I guess the condition for both of them is x is greater than 0, as you can see. So, معرفش الناس بتيجي تخرج كده الموضوع صعب. يبقى x is greater than كام؟ 0. يبقى انا هنا قدرت ان انا احدد مين؟ الدومين. يبقى اذا اقدر اقول ان x I can say also x belongs to R positive. يبقى انا كده على طول قدرت to identify the domain of this function. We will show some examples to cover this, and you have plenty of problems in the previous exams and previous midterms. We are given a vector valued function of one real variable, as I told you. So I will start with f1, which is 1 over x, it should equal to 0. And for the radical, x must be greater than or equal to 0. I will combine both of them together, so x must be greater than 0, which means from 0 up to infinity, or x belongs to R positive, as we wrote previously. Now I can write the domain in this case. Look, Omar, because I want you from the challenge, I want you to try and to exert an effort, real effort, to make your writings readable and beside each other, okay? This is important. You are studying very well, but I need to be able to read them also accurately, okay? So, I will write like this, Mr. Hamad, the domain of f, relative to the f function, the domain of f, is x belongs to R, such that x doesn't equal to 0, and this is the sign of and. It means an intersection. So this condition and this one too, they have to be approved. So x doesn't equal to 0, and x is greater than or equal to 0, which can be written as R positive. فاهمني؟
لازم اكتب الايكويشن دي ولا ممكن اعطيه لو
ممكن اكتب ار بوزيتيف بس تبقى فاميليار بيهم لان الاسره اسئله هتجيلك كده.
تمام.
فلازم ابقى فاهم ده. Why not to try it? If you try it once, twice, you will be able to try it this way. ماشي؟ Okay, so once more, as I told you, let's see this problem. حازم بصي على المسألة دي شايف ايه؟ f of x, y, and z. So the input is 3 variables. And the output, look to the output. How many functions? This is number 1, number 2, and number 3. So actually what we are saying now is a function f such that from R3 into R3. If I'm taking variables in 3 dyne and then imaging them, or the codomain will appear, or the functions in the image, in the after the function act, it will deliver 3 outputs. I need to find the domain. So what to do, Omar? I will discuss every one of them separately. So I will discuss for f1. This is f1. f1 is equal to lim of y. How to use lim y in this case? Y must be greater than 0. That's the condition for y. Okay? And look to f2. f2 is e to the power of x plus 1. Do you have regulation for the exponential function? Do you have something will make exponential functions goes wrong? No, you don't have. So it means x belongs to r. So here x belongs to all the set of real numbers. And then you have f3, which is a radical of bar, a quarter, or a fourth radical, or a fourth root. Which means for this even root to be working, z must be greater than or more than 0. So I have 3 conditions. They will have to be written in order to be able to use this function. So I can write, as you would see, that the domain of f, is x, y, z belongs to r, and such that I will insert each condition that's written in this function. So once more, as I told you, let's study each one of them. This is y greater than 0 for the length. This is x belongs to r, that's z greater than or equal to 0. Then I will write that x, y, z, those are the variables, the input, which r belongs to r cube. Why r cube? Because x ranges from negative infinity to positive infinity, y ranges from negative infinity to positive infinity, and z also. So we are talking about r3, such that x belongs to r, and y is greater than 0, and z is greater than or equal to 0. Now I have an exact definition for each one of them. شباب انتوا معايا؟ واضحة؟ Okay, very good. There is more examples on the part of the domain and range. This is of the domain first, and we will go to the range later. So if I have f of x, for example, equal 9 minus b of x squared. If I'm having, okay, this function, how to look at it? It is f of x, which means y, equal to the root of 9 minus b x squared, where b is a constant. So the first step is to write y equal to the root of 9 minus b x squared. This is an equation of an ellipse or a circle. So now, since I know that's from where did you know that's an equation of an ellipse or a circle? Because I know that the equation of a circle is like x squared, okay, plus y squared equal to a squared. And the ellipse equation, which is a circle and the center is at the origin. The ellipse is going to be exactly the same, but with different radiuses. So it will be x squared over a squared plus y squared over b squared equal to 1. And in this case, this is the shape of an ellipse. Since this value is not defined for me, this p is not given, so it may be a circle or it may be an ellipse. Okay? So now I will need to see that how to get the condition. So from what's here, I have that 9 minus b of an x squared must be greater than or equal to 0. This is how to get the regulation, which means 9 is greater than or equal b over x squared, which is also like writing bx squared is greater than or equal 9 ya Omar. That's x squared greater than or equal 9 over b, which leads to, خلي بالك, once you take a square root, you will have the same sign with the positive and the opposite sign with the negative when it appears, which means x is less than or equal 3 over root b, and the x is greater than or equal to negative 3 over root over b. Combining these relations together, I will be able to identify the region that I'm talking about, which is simply x belongs to from negative 3 over root b till 3 over root b, and that's the domain, as you will see. Okay, so once more, as I told you, that's y equal to the root of 9 minus bx squared. So it's going to come up to 9 minus bx squared must be greater than or equal to 0. So 9 must be greater than or equal to b of x squared. See how I'm manipulating the signs, okay? How I'm moving around them. So x squared is less than or equal 9 over b. So x is in between negative 3 over root b and 3 over root b. If you try to draw what you have here, it's a circle, and it will appear to you as you can see that's the case. Here's 3 over root b, that's negative 3 over root b. This is for problem number A. For problem number B, I have a function in x and y, and it is represented in R, which is a function in several variables. It's not a vector valued function, it's a function in several variables. So also I will look to the condition. Has a condition اللي عندي. I have x divided by y minus 2 over x. I have x divided by y minus 2x. And of course, it's moving from R2 into R, from 2 dimension into 1 dimension. The condition is y minus 2x should never equal to 0. So in order to define the domain, the denominator can't be 0. That's y minus 2x never equal to 0. Which means y shouldn't equal to 2x. So the function is defined everywhere, but not when y is equal to 2 of x. بص عايزك تعرف حاجة في الرسم. Okay, there is a relation about graph. If your function is in 2 variables, then the graph will be and the input. If the input is in 2 variables and the output is just only 1 function, so you are talking in 3 dimensions. Then we'll go through the graph shortly, inshallah. So if you remark z equal to a function in y of x, I can say this function is equal to z. So the name of the function is z, and it depends on how many variables? 2 variables. That means I have 3 values. 2 input, which is y and x, and 1 output, which is the z function. Okay, the z function. Okay, in this case, we will depend on using the values of the plane xy to give the corresponding value of z, and I will show you this shortly, inshallah. That means if this is x and y, that's the line of y shouldn't equal to 2 over x. And I will start to make substitution by using numbers in x and y, and the values will be represented in the z dimension. معايا حسب؟ وانا كل ما ادخل y و x هنا، ما ادخل numbers هنا، الفاليو اللي هتطلع هتبقى الفاليو بتاعت الz variable. You understand what I'm saying? So you are playing in this plan, and whatever you do as a substitution in y and x, it will give you the value of the z variable. So this is actually the shape of what you are going to see. Of course, the function is not defined when y equal to 2x. So the line y equal to 2x, any values belong to this line, your function is not going to be defined. Okay. Also for problem number C. Problem number C, it needs more study. Please look at it. For problem number C. Problem number C, you will have the ln of x over y. So I'm getting a ln of x over y. The first thing that comes to you, that y shouldn't equal to 0. Because simply it's a denominator. So that's number 1. Number 2, x should be greater than 0. So now I have 2 conditions. The first condition is y doesn't equal to 0. And the second condition is x is greater than 0. This condition will make the inside then work. And that condition will make the denominator to work. But also, Omar, I have the ln of the division of both of them. And this then requires that all the values coming out from those 2 values, or from the denominator and denominator, must be positive. So I need to be sure that when the values of x and divided by the values of y, it's going to be positive. And when it's going to be also positive if there is another solution. So I will do it in this manner. I will study the case when x is greater than 0, but with the condition y is greater than 0. So I will do the following. Ln x must be greater than 0. That x must be greater than 1, and y should be greater than 0. That's the first relation. Okay? The second, when ln x is less than 0. When ln x is less than 0, ln x is less than 0 between the portion of 0 and 1. طبعا Hazm, yes, you are right, Hazm, because all of us understand that y equal to ln of x, this is the graph of the ln logarithmic function. Look, this is the graph. So this number is positive 1. I'm talking about ln x يا عمر، ما تخرجش، استنى. ده y، ده كده ln x. خلي بالك الفانكشن اللي انا بتكلم عليها فيها لين اكس الدينومينيتور صح؟ طيب انا عايز اشوف اللين اكس اللي على الدينومينيتور ده ماشي؟ اولا ما ينفعش يبقى بزيرو اوكي؟ يبقى اذا ما ينفعش يبقى بزيرو. بعدين عايز اللين اكس اللي فوق ده يبقى بوزيتيف.
ماشي.
امتى اللين اكس يبقى بوزيتيف؟ بص كده الفاليو اوف لين اكس از بوزيتيف once x is greater than كام؟ يعني for x is greater than 1 ln x will be positive. انا بتكلم I'm talking about the x values that will make ln x as whole positive. يبقى اذا the values that will make ln x positive يعني ال y positive هي all the values greater than كام؟ greater than 1.
مش المفروض greater than 0؟
لا
عشان كده بص
اللين greater than 0 بس انا ده عشان يورك.
ماشي.
بس هو لما بيورك اللوجاريثماتيك فانكشن بتدي لك بوزيتيف فاليوز وبتدي لك نيجاتيف فاليوز. بص على الرسم
ماشي.
الجزء ده بوزيتيف اهو بوزيتيف واي والجزء ده نيجاتيف واي.
ماشي.
ماشي. مش انت عندك لن اكس على واي
ماشي.
ودول هما الاثنين راكبين ورا مين؟
رجلي فعلا.
يبقى انا عايز الاثنين دول مبدئيا يكونوا دايما هم اكبر من كام؟
زيرو.
يعني يبقوا بالايه؟
بوزيتيف.
امتى يبقوا بوزيتيف؟ لما اللي فوق بوزيتيف واللي تحت بوزيتيف.
ماشي.
وامتى تاني يبقوا بوزيتيف؟ لما اللي فوق نيجاتيف واللي تحت يبقى ايه؟ نيجاتيف. صح؟ عايز اضمنها بقى، اضمنها ازاي؟ اما اجي اقول له ايه؟ when y is greater than 0 يعني كده y ايه؟ بوزيتيف.
ماشي.
عايز اضمن انا لين اكس يبقى بوزيتيف. امتى لين اكس يبقى بوزيتيف؟ يبقى بوزيتيف لما اكس از جريتر ذان كام؟ لا 1.
ماشي 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 انا فهمت.
اهي دي لين اكس دي واي بيساوي لين اكس. يعني النومينيتور هو اللي انت شايفه قدامك ده. دي الفاليوز بتاعت لين اكس يا عمر شايفها؟ مش ده البوزيتيف، مش ده البوزيتيف سايد؟ مش ده كام البوزيتيف؟ يبقى امتى يبقى بوزيتيف؟ لما الاكس تكون اكبر من 1 يبقى اللين اكس بقى موجب.
تمام.
يبقى هنا لما y greater than 0 بس معاها and x is greater than كام؟ طيب هو برضه ممكن الاوفرول يبقى بوزيتيف. اوفرول ده بوزيتيف ده يحصل امتى؟ لو اللي تحت نيجاتيف يعني y less than كام؟ بس معاها لازم قيمة اللين تبقى النيجاتيف. The value of the len function should be with a negative. The negative will happen when x is greater than 0 and less than 1. يعني لو انت في الحته دي الفاليوز بتاعت اللين بتبقى بينهم.
ماشي ماشي ماشي. بس دي
فهمتني؟
الحته دي كلها رول في الليل بشكل عام مش في المساله دي.
لا مش اللوجاريثماتيك ده الشيء اوف اللوجاريثماتيك
خلاص
فانكشن.
ماشي.
ماشي؟ يبقى in this case خلي بالك يا حازم انه ازاي انا بقدر اولا سنه بسنه. خلي بالك الجزء بتاع الدومين ده اتس ريلي فيري تريكي. هاو ماني كونديشنز لو سمحتوا المساله دي مهمه قوي. هاو ماني كونديشنز؟ 3 conditions. او first of all y doesn't equal to 0 out. Second اللين x must be greater than 0. يبقى اذا x greater than 0 بس x greater than 0 is not gonna work forever. I will divide greater than 0 from 0 to 1 then from 1 up to infinity. From 0 to 1 the value of ln x will be negative. So I need to be sure that y is less than 0. So both of them are negative or negative, so the result will be positive. The outer limb will work. Or the numerator is positive while the denominator is also positive. The denominator will be positive when y is greater than 0. Here, y is greater than 0. The denominator will be positive once x is greater than 1. يبقى إذا x is greater than 1 and y is greater than 0. Or if x is between 0 and 1 and y is greater than 0. You can go to watch this. This is how it should be written. معايا يا شباب؟ معايا؟ اوكي. طبعا ده الشيء اللي بيظهر عندي من الفانكشن دي. As I told you, the values of x and y and after taking the len, it will give you the outcomes of the z function. So whatever you are substituting by in the x or y plan, it will appear in the z function or in the third variable. Now I want to talk about the domain of real functions, the domain of a function f from Rn into R, which means the domain of several variables, functions and several variables. A set of points in Rn whose entries, when replaced in the general expression of f, produce a real number. So let's once more, look to this problem. Of course, this problem is a second variable function, but it has plenty of conditions. How many conditions? It's like a puzzle. You will have to love it in order to be able to solve it. If I look to it, I will have, that's a condition, the inside is a condition, the logarithmic function to work is a condition, and the denominator is also a condition. So how many conditions you will have to satisfy? 3 of them. You have to be sure about the 3 conditions that appears in front of you. So I will start. The first thing is to be sure that x squared minus 4 is greater than or equal to 0. That's for the radical to work. For the len to work, all the values behind the len or the argument should be greater than 0. So I have, this is the first condition. So this is condition number 1. That's the condition number 1. The radical one. And that's the condition for the len to work. And that's the third condition for the denominator to work. So I have 3 conditions, as you can see. I will start to analyze each one of them. Of course, the intersection of these 2 guys is x squared minus 4 is greater than 0. Not greater than or equal, greater than 0. So now I have x squared minus 4 is greater than 0. Don't use the equal sign, because then rejecting equal sign. You read what I'm saying? The second step, it will lead to x squared is greater than positive 4. As I told you previously, once you have an x squared is greater than a number, take the square root for both sides, which leads to